Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from October-November 2023, paper 5. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 16 says an electric kettle contains 4.25 times 10 to minus 4 cubic meters of water. The temperature of the water is 22 degrees Celsius. The kettle is switched on. The water takes 85 seconds to reach a temperature of 100 degrees Celsius. Show that the power of the kettle is about 1600 watts. And specific heat capacity of the water is given to us and density of water is also given to us. So how we can approach this problem? After reading this question, you need to understand is that this question is about specific heat capacity. So we will start with specific heat capacity. So simply we will say Q is equal to MC delta T. So this is the thermal energy supplied. But for this question, we need to calculate the power. So this is the energy. If we divide this one by delta T, so that becomes power. So if we divide this side by delta T, we also need to divide this side by delta T. This side also by delta T. Now we can rewrite this formula. So this is power. So this is MC delta T divided by time taken. So this is how we can calculate the power. So mass, but mass is not given to us. Mass is not given to us. So mass we need to understand. Mass is equal to density times volume. So we can plug in value of mass, means we can write down mass is equal to density times volume. So we can write down here. This is a beautiful way. This is how you need to approach in a systematic way. So this is delta T and this one is time. So now simply we need to plug in values. And if we plug in values, our answer will be about 1630 watts. So in this case, we no need to change the units because already temperature is given in degrees Celsius. But you need to understand the difference in temperature in degrees Celsius is equal to difference in temperature in Kelvin. So it means you can directly use temperature in degrees Celsius. And if you plug in values now, this will be the answer. Now let me show you the answer how I have solved. So if you plug in numbers, this is one way you can also answer this question. So in this case, first of all, I have calculated what is mass. So this one is the mass. Then we are using this formula. So I have calculated amount of thermal energy supplied. Then I divide it by time. So that is the power. But you can also simply use this one because this is important for your understanding. Part B says the water boils at 100 degrees Celsius. Calculate the time now taken for 75% of the water to boil away. Specific latent heat of vaporization of water is given to us. So the time taken we need to calculate. So again we can use the same approach. So if you read this question, you can see from here, this is about latent heat of vaporization. So simply we can say latent heat of vaporization, simply Q is equal to M times L. And in this case, 75% of water boils away. 75%. So it means this is 0.75 of water or 0.75 of the mass of water. So this is 0.75 M. M is the total mass of the water times L. So we can calculate Q. As for this one, we need to find out time, but P we have already calculated. So then we will be able to find time. We will go to that point later. Now simply you need to plug in values. So we have 0.75. Again, you can say rho times volume times L. And you can plug in, you will be able to get value of Q. And when we have value of Q, and this is the L actually, this is latent heat of vaporization. So this is LV, latent heat of vaporization. So this is latent heat of vaporization. Now simply we need to plug in and we will get value of Q. Now when we have value of Q, then we need to understand is that P is equal to Q over delta T. But we need to find out delta T, so this will be equal to Q divided by P, and the value of Q we have from here, and we will divide by value of P we have calculated in the last part, that was 1630, and we can find out value of time. So this is how you need to approach. Now let me show you the answer with numbers. So here I have done this one with numbers. So simply you can check here what we have done. First of all, we have calculated delta E. So this is value of the Q for 75%. So this factor is why? Because for 75%. So this is then how we have calculated time. Pretty straightforward question. So when you do question, try to understand the logic. That's the reason at the beginning I solve question without numbers, and then I use numbers. Before we go to next question, I want to explain you one very important point. So Q is equal to ml. Now can you tell me what m is representing here? M is not, if you simply say m is the mass of water, that is wrong. M is mass of water. You have to be very clear. Mass of water boiled away. Very important one. So this is the misconception many students they have. This is not explained in this way in the class. So M here is not only mass of water. It's mass of water boiled away. Mean this amount of thermal energy caused this much mass of water to boil away. So that mass you have to use, not the mass of water. So this is what this one is representing. Mass of water boiled away. Mass of water boiled away. So this question can be asked you in a different way next time. So if your basic concept is not clear, you don't know what M is representing, of course you will struggle to answer the question. Question 17 says Makemake is a dwarf planet in the solar system. Makemake has a mass of this much and a radius of this one. Calculate the gravitational field strength at the surface of the Makemake. So simply in this case, let's try to understand what is given to us. So this is the planet, dwarf planet. The mass of this one is given to us. So in this case, let's say this is representing M, and the radius of this one is given to us. And we need to find out, so this one is the radius. We need to find out what is value of G at the surface, mean at this point. We need to find out what is value of G. So this is pretty straightforward one. So the G will be equal to G at surface. So we are talking about G at surface. So simply you can say G capital M divided by R square and plug in values and you can find the answer. Now let me show you this one with numbers. So if you have plug in values using this formula, your answer will be equal to 0.40 newtons per kg. Part B says the average distance of Makemake from the Sun is similar to average distance of the planet Pluto from the Sun. A website states the time taken by Makemake to complete one orbit of the Sun is 20% greater than the time taken by Pluto to complete one orbit of the Sun. Assess the accuracy of the website statement. So we have mass of the Sun that is given to us, orbit radius of Makemake is given, and orbit time of Pluto is given to us, and it is also given to us 1 year is equal to 3.15 times 10 to 7 seconds. So in this case, first thing you need to understand, what do you need to calculate? So we need to prove that time taken by Makemake. So we can say the time period of Makemake. So this is simply time of Makemake. This is 20% greater than time taken by Pluto. So if we divide the time taken by Makemake divided by time period of the Pluto, mean time taken to complete one cycle, this ratio should be equal to 1.20, means 20% more. If the time period is the same, will be 1. As the time period is 20% greater, so your answer should be 1.20. So to reach this conclusion, what we need is, this is already given to us. We have time of the Pluto, so we need to calculate time, orbital time of Makemake. So if we have, we can plug in here, we can find the answer. Now the question is that, how we can find out the orbital time of Makemake? So we need to go back to Newton's law of gravitation. So Newton's law of gravitation simply tells us, if we have this is our sun, so this is sun, let's say this is planet Makemake. So the gravitational force between them we can find, and that gravitational force is providing the centripetal force for Makemake. So this one will be Ft, gravitational force in this case is providing the centripetal force. It's not equal to centripetal force, because centripetal force is not a force by itself. Now simply we can write on here, so this is G capital M, means this is capital M is the mass of the sun, small m is mass of the small planet, divided by the orbital radius square, and this has to be equal to mr omega square. So we need to calculate time. So from here we can find out this m, we can cancel with this m, so we can find out what is omega square. Omega square will be equal to G capital M. If we divide both sides by r, we will get this one is r cube. So we can find out value of omega. So from here we can say omega, so divided by s. So here we can write down now. So this will be Gm divided by r cube. If we take square root of this one, we can find out value of omega. And when we have value of omega, then we can find out time period, because omega is equal to 2 pi over t. So from here we can find out value of t. So this is how you need to approach. In this case, this is in kg, so simply you can use, and radius is in meters, we can directly use. But you have to be clear about this one. This has to be the orbital radius, means the distance from the center of the sun to the center of the planet. Orbital radius must be given to you. If they simply give you the radius of the sun and radius of Makemake, and they give you the distance from the surface of this one to the surface of this one, then in this case the orbital radius will be equal to radius of the sun plus distance from surface to surface, means this distance d, plus radius of Makemake. So in this case, r here, so I'm saying this is orbital radius, distance from center to center, center of planet to center of sun. So this is, then you can find out t, and when you have value of t, so from here you can say t will be equal to 2 pi divided by omega, then you can plug in here and you can find. If the answer is 1.20, it means it's correct. If greater than, it means statement is not valid. If smaller, also statement is not valid. So this is how you need to approach. Now let me show you the answer with numbers, how you can do this one with numbers. So I hope this makes sense to you. So I will simply clean this one and show you with numbers now. So this is how we have done with numbers. So you can see, first of all, we have found omega, and then we have find out value of this omega angular speed in this case. Then we have calculated time period. So here we have converted this one into years, and here we have divided. So we have found 1.24. So it means this is 24% more than time period of Pluto, orbital time of Pluto. So it means statement is not quite accurate. So this is how you need to approach. I hope this makes sense. And if you have any questions, please leave your questions in comments. I will try to answer as soon as possible. And if you are looking for extra resources, you can join Patreon On Patreon, you will see a lot of resources, exam revisions, and a lot of other resources. Question 18 says, in January 2023, the asteroid 2023 BU came close to the Earth. The closest distance of asteroid from the surface of the Earth was 3,590 kilometers. Calculate the force between the asteroid and the Earth at the closest distance. You may assume the asteroid as a sphere. It's a sphere. Asteroid diameter is given to us, asteroid density is given to us, mass of Earth is given, radius of Earth is given. So we need to calculate force. So first of all, we will go to the main idea, how we can calculate force between Earth. So this is our planet, this is Earth. Let's say the mass of this one is capital M and this one is asteroid. Mass of this one is small m. So we need to calculate the force between these two. So gravitational force, so this is the force. So we need this distance. But for this question, what do we have? We have diameter of the asteroid, that is 5.65 meters. So it means we have to take the radius of this one. So this radius we need the radius of this one, and we need this distance. So that is the d. So d will be equal to, let's say radius of this one is capital R and the radius of this one is small r. So d will be equal to capital R plus, let's say this distance, we can say this one is R1, distance from the surface of Earth to the surface of this asteroid. So we can say that is R1 plus R, this one. So this is the distance from center to center. Now we need to use Newton's law of gravitation. So this is G capital M small m over d square. And so for this one value of G we have, this is a constant value of M capital M, mass of Earth is given to us. So we need to find the mass of the asteroid. So how we can find out mass of asteroid? This is a sphere, so this has to be equal to density times volume. And the density and the volume we can simply find out as it is a sphere, so 4 pi r cube. And now if we plug in values, we can find out the mass of asteroid. Then we can plug in values here, we can find the answer. So d is very important one. So d is the distance from the center of Earth to the center of asteroid. As in this case, the diameter of asteroid is very, very small. So we can ignore that one. The radius even will be smaller, that can be ignored. But the radius of Earth we cannot ignore, because radius of Earth is 6,380 kilometers. And this is 3,590 kilometers. This is the distance from the surface. So in this case, let me explain to you. This distance is given to you. This distance, this is given to you. From the surface of Earth, the closest distance value is given. And this distance also, we can take, this is taken from the center actually. So this distance is not from surface to surface. This distance is from actually the center. So it means these two, they are equal to this distance. So this is, so it means this is equal to 3,590 kilometers. So this is only the tricky part. You have to be clear which distance you have to use, and then simply plug in values and you can find the answer. Now let me show you the answer, how we can answer this question. So let me show you the full solution of this one. I hope this makes sense to you. Now please, simply you need to plug in values. As you can see here, first of all we have calculated the volume of asteroid. So this is volume. Then we have calculated the mass, and then we are simply using Newton's law of gravitation, mean the formula for gravitational force. And this one is the distance of closest approach. Let me explain you again. Distance of closest approach we are taking from the center of asteroid to the surface. So this distance is given. So is this one, and this one is the radius of Earth. So we have to take this r as well. So this one is r. So this is given in kilometers, so we have to convert it to meters. So this is the final answer. So the distance of closest approach, or the closest distances from the surface of Earth to the center of this one. They can also give you the distance from the surface of asteroid to the surface of Earth. Then you have to take the radius of asteroid as well. But in this case, radius is very small, so that can be negligible. Part B says calculate the change in gravitational potential energy of the asteroid if it had fallen to the surface of the Earth from a height of 3,590 kilometers. Assume that mass of the asteroid remains constant. So first of all, let's sketch and try to visualize. Let's say mass of Earth is capital M and this one is asteroid and its mass is small m. And let's say this point is 2 and this point is 1. So we can also take, this is at the surface, so we can take this distance, and let's say this distance is r1, and this distance means the distance from the center of asteroid to the center of Earth. Let's say this distance is r2. So we need to find the change in gravitational potential energy. So simply we can say delta GPE. This one has to be equal to m times change in potential. M is the mass of the asteroid. So we can take this as m. So the change in potential. So we can find the potential, final potential. So we can say here final potential minus initial potential, means potential at this point. So it means this is m. So the final potential, that will be G capital M divided by R1, but potential is negative, so negative sign we have to use, minus potential due to this one. So this is negative G capital M divided by R2. So this is, now if we little bit simplify this one, so in this case we can write on this one m. So here we will get, this is G capital M divided by R2, so this is positive. So here we have G capital M divided by R1. So this one is negative. Now if we take negative out, so we can take negative, this is G capital M small m, we can take out. If we take negative out, so this will be negative, this will be positive, so this will be Gm over R1 minus will be G capital, actually we have taken out already, so we can simply write down, this will be 1 over R1 minus 1 over R2. So now simply we need to plug in values. We have the formula, now simply plug in values and you can find the answer. So what is R1? Is the distance from the center to the surface. So this is the radius of Earth. And this is the distance, radius of the Earth plus this distance. It means here R2, let me write down. This will be radius of Earth plus this distance, 3,590 kilometers. Now simply plug in values and you can find the answer. So this is how you need to approach. So if it is moving from this point to this point, getting closer, it means the potential energy is decreasing. So the answer should be negative. And if it is moving away, potential energy should be increasing. So the change in potential energy has to be positive. So let me write down here. If it is approaching, mean getting closer, what will be the change in potential energy? Delta E. It has to be negative. So the answer must be negative. And if it is moving away, so we can say moving away means going away, change in potential energy has to be positive. So in this case, as it is approaching, so change in potential energy, because the potential energy is decreasing, so it has to be negative. It's same. For example, if this is the planet, this ball go away, what is the change in potential energy? positive. If it is falling, what is change in potential energy? Negative. So in this case it is falling. That's the point you need to understand. So approaching means falling, we can say in a simple language. It means moving away. You can say rising. So this is. Now simply we need to plug in values. Now let me show you the complete answer. And so here you can see we have already derived this formula. We have written in this form. Now simply we need to plug in values. So this is the radius of Earth, this is radius plus the distance, and this is our final answer. Answer in this case has to be negative because the change in potential energy is negative. If you simply remember this formula, so what is this one? This is the closest actually. Closest. This is closest distance. And this is further away. So we can say further away. So this formula you can also remember, otherwise you should be able to derive this one. Derivation is important because that will give you understanding. Part C says explain why the mass of the asteroid would not remain constant as the asteroid fell to the surface of the Earth. So in this case simply we can imagine this is our planet and there is an atmosphere, there are air particles all around this one. As asteroid is falling, this will interact with the air particles. So the kinetic energy will be converted into thermal energy. So due to the thermal energy, means due to heat, this will burn. So its mass will decrease. So these are the points you need to understand. So how we can write on the answer? So in the answer we can talk about these 2 points. We can say air resistance does work on the asteroid. When asteroid is falling, so there will be resistive force on the asteroid in this direction. So resistive force, and the work done by this resistive force will be negative. Asteroid is falling down and the force is in upward direction. So it will lose actually potential energy. As it will lose its potential energy, and that loss in potential energy will not be equal to gain in kinetic energy. That part of that one will be converted into thermal energy, and due to thermal energy this will heat up and it will burn, it will lose mass. So asteroid heats up and may burn due to atmosphere entry. So in this case asteroid is falling, even if we imagine it started from rest, so its potential energy has to be converted into kinetic energy. But due to air resistance, all the potential energy will not be converted into kinetic energy. Some of energy will be converted into thermal energy. So it will heat up. So it will lose mass due to burning. Question 19 says, in 2023, a small capsule of cesium-137 was lost when being transported from a mine in Western Australia. The activity of the cesium in the capsule was 19 gigabecquerel. Show that the decay constant of the cesium is about this one. And we need to be careful. This is in seconds. And half-life of cesium is given. This is in years. And 1 year is given to us is equal to these number of seconds. So we need to, half-life is given. We need to find out decay constant. So decay constant is equal to ln 2 divided by half-life. Ln 2 is a constant. So half-life simply we need to convert into years and we can find the answer. So in this case we can say this is ln 2, and how many years we have? 30.1. 1 year has this many seconds, so 3.15 times 10 to 7. Now if we solve this one, we will get the value of lambda, that will be in per second. So this is how you need to answer. Now let me show you the full answer, and also this answer is written a little bit in detail. So you see, first of all we have used this formula. So let me clear this first. So this is the formula first of all you need. Then you have to convert time into years, then use the formula, and this one is final answer. For the second part, we need to calculate the mass of cesium in the capsule. So how we can calculate mass of the cesium? Density, volume, those informations are not given to us. So you have to little bit think about this one, how you can calculate mass. So in order to calculate mass, so let's say this is capital M. If we can find out total number of nuclei and we have mass of one single nucleus, we can multiply and we can find the total mass. So we can say, if we can find out total number of nuclei of cesium and we have mass of one nucleus, so we can find out total mass. And mass of one nucleus we can find out because this is cesium 137. So we can write on this is N. Mass of one nucleus is equal to the number of nucleons multiplied by mass of one nucleon. And mass of one nucleon is means mass of one proton or neutron is 1.66 times 10 to minus 27 kgs. So this is the main idea you need to approach. So this is how we can figure out. Now we need to find out value of N. How we can find value of N and which formula we have in nuclear physics which relate decay constant N and activity. So you need to little bit recall. So we have formula A is equal to lambda times N. We have initial activity, we have calculated lambda, so we can find out N. So it means N will be equal to the initial activity divided by decay constant. So if we plug in, we can find out. Initial activity was 19 gigabecquerel, 10 to 9. And value of lambda we have just found in the last part. So if we plug in values, so we can find N, then we can plug N here and we can find out the mass. So this is how you need to approach. Now let's go through the complete solution. So this is the main idea. This is what you have to develop in your head, how to approach. Then you can plug in numbers, you can find the answer. My main purpose of this solution is to help you to understand how to answer the question, not every time you stuck with new question. So this is first how you need to organize your thoughts. Now let's go through the complete solution. So here you can look at complete solution. So you can see I have written first of all this formula. Then I have calculated value of N using this formula because initial activity we have, decay constant we have calculated in the last part, and mass of one cesium nucleus is this one. This is mass of one nucleon, and then we multiply total number of nucleons. So these are total number of nuclei of cesium in the sample, and this is our final answer. For the third part, we need to calculate the activity of the cesium in the capsule after 2 years. Very straightforward question. We have initial activity. So we have initial activity. Now we need to find out after a certain period of time. So A as a function of time is equal to initial activity times e to the power of decay constant times time. Time passed. Time passed between these two means when this activity decreases to this one, how much time has passed, that time is here. So this is activity, remaining activity after time t, and this is the time taken from initial activity to decrease to this value. Now we have all the values, simply you need to plug in and you can find the final answer. But you have to be careful. This time you have to convert into seconds. That's the point simply you need to do. Now let's go through the answer now. Nothing else to discuss here. So the main concept I have already explained. Now you see what we have done here. We have simply plugged in values. So t we have converted into seconds. Then we have simply used this formula and this is our final answer. Initial activity was 19 gigabecquerel. Now we have 18.1. Part B says the capsule was found after 14 days. Calculate the total energy in joules released from the capsule in 14 days. Activity of cesium capsule is given to us. Energy released in each decay of cesium is 1.17 mega electron volts. 1 day is equal to 86,400 seconds. So when you read the question, how we can answer? So what do we need to calculate in this case? We need to calculate total energy released. Total energy released, and answer should be in joules. Total energy released. So if we can find out number of decays in 14 days, so we can multiply with energy release in 1 decay. So what we need to find out? We need to find out n, number of decays in 14 days, and then we multiply with energy release in 1 decay. So we can say energy released per decay means energy released in 1 decay. Then we can find out the total energy release. So this is the main physics. So how we can calculate number of decays? So look at this one. Activity is given to us. So what is activity? Activity is telling us number of decays per second. Number of decays per second. So this is given in becquerel, mean number of decays per second. So this is given to us. So we have how many decays are happening in 1 second, and if we have the total time, we can find out total number of decays. So how we can find total number of decays? So we will be writing here total number of decays. How we can find out? In 1 second, how many decays we have? 19 gigabecquerel. 19 giga, 19 times 10 to 9 number of decays we have in 1 second. And how about the total number of seconds? Total number of seconds will be 14 times number of seconds in 1 day, that is 86,400. That is given to us. So by solving this one, we can find out total number of decays. So now we have total number of decays, we have energy released per decay, we can calculate energy released in 14 days. Then that answer we can convert into joules. So this is how you need to answer. I hope this makes sense to you. Now let me show you the full answer. So here is the answer. In the answer, you can see, first of all, we have calculated number of decays, and this is the energy released in 1 decay. We have converted into joules. Now simply we multiply number of decays with energy released in 1 decay, and this energy is in joules. So our final answer is also in joules. So this is how you need to answer. And today's lesson I will stop here, and remaining 2 questions I will try to upload as soon as possible. And if you have any questions or if you have any doubts, please leave your questions and your doubts in comments, and I will try to answer as soon as possible. And also, if these videos are helping you, please like and subscribe, and also leave some comments, and also share with your friends. And if you're looking for more resources, you can join Patreon. See you in next video.